All right, we are live. So everybody, welcome to the Malware Analysis Fundamentals or Intro to Malware Analysis workshop put on by ACM Cyber. So a very big thank you to Nicole Wong. She had a conflict with another class, but I am really hoping that everyone recognizes the fact that all of this work was done by her, or I should say all the preparation. All of this workshop is actually a reiteration of one that I attended and I believe Nicole attended over summer. So the actual content and thinking is not necessarily all of ours, but it's been inspired by a workshop we attended. And Nicole did all the preparation on the slides and basically the guide that I'm using to present this. So big thank you to Nicole. All right, and hopefully I'll see that one. All right, so who am I? I'm Chris. I'm Necrosis on Discord. I'm still a noob. And again, I'm just a sub for today. So today we're going to be talking a little bit of malware, some bombware, and maybe some ambyware. Yes, I make up my own words. So hopefully you guys enjoy that. And if you missed it, the check-in code was analysis, analyze in leak code. So please speak. All right. All right, so today's agenda, we're going to be talking about the malware fundamentals, examining some malware characteristics, and then doing some demos with these items. So malware analysis, the process. So first, obviously, you're going to need to obtain malware from a compromised system. And there's a lot of ways to do this. You can get them from like websites that have repositories for research. Maybe your family member or your own computer had malware on it. And so then the second one is you're going to analyze it in typically two different stages. The first one's static analysis, where you don't actually execute the program, but you use all the tools available to analyze the software without executing. Dynamic analysis is where you actually execute it. So that's where you run the malware and allow it to do all the bad things it does, obviously in a controlled environment. So, and then the last part is reporting. So once you've done all your research, you need to report out what it does. So again, static analysis, this is where you analyze malware without execution. You're looking for signatures or signs. So you're looking at the code itself for this, or maybe you're looking at features around the code, like how it's delivered. So you can be doing hashing, reverse engineering, doing some reversing for file obfuscation and packer detection. We'll dive into that a little deeper with packer detection. And again, so this only gives you hints or clues, whereas the dynamic analysis, which we'll talk about here shortly, is going to confirm those clues. So dynamic analysis, this is where, again, we're running the program to execution. It analyzes the behavior, detects signature. So maybe it's making different API calls. There's changes in the registry files on your computer. What kind of network traffic? Maybe it's going to specific websites or URLs. So those are the main two kinds of analysis that we'll be talking about. So the first thing you want to do when you're working with malware is, because it's so dangerous, and as you all probably all are aware, that you can actually spread this fairly easily to open networks. So when you build your virtual machine, you're going to want to make sure you close off the environment. So host only network mode, keep it segmented from the internet. I take it one step further, is you want to just remove all networking from it until you're ready to do like safe network analysis on it during the dynamic analysis. And so then the other nice thing about virtual machines is if you do run a piece of malware, you can always revert back fairly easily with snapshots. So when you do your samples, you want to password protect them. And this means you would put them into a zip file and password protect that and encrypt it. Make sure that no one can just break into your virtual machine and then let loose some crazy malware. And then defanging your URLs. So this is a technique where malware will be making a call to a website or a URL. And sometimes those URLs can't be taken over by the federal agencies or police departments. So what you want to do is you want to go in there and like one example might be to replace the T's in HTTP to X's. So then this way, when it tries to make that call, it's not going to be able to because there's no HXXP protocol for it to use. Yes, so that's actually a great question, which is here on the very top line, is that yes, indeed, more advanced malware is able to detect the virtual machines and basically hide their behavior. Another thing, which I believe is also mentioned later, but I'll just talk about now, is it can also find vulnerabilities in your virtual hosts and then break out onto your local machine. So yes, malware is very advanced in some cases today, where you want to be careful with how you're performing your analysis. This is one of those kind of lectures where you have to, don't try this at home, kids, kind of thing, right? But yeah, so detection features, right? This is for the analyst point of view, right? Is we can run signatures from the hardware or remote access Trojans. We can detect debuggers and decompilers. So then, if a malware detects these things, this is talking about them being in the virtual machine, they can just stop working. Like they'll just be like, hey, oh no, we see this stuff. We're going to shut down so nobody can analyze us. Sleep feature, again, wait until stuff happens. They can also find vulnerabilities because some of the analysis tools are no longer supported. So if anyone wants to start supporting them again, that'd be great. And yeah, launch zero-day attacks against the host machines and change characteristics. So if it's supposed to be a remote access Trojan, it might not actually open any network connections anymore. It might just turn into like ransomware and encrypt the whole drive. So there's a lot of options there. So how do you hide your virtual machine? So this is the defense against these tactics is you're wanting to make it look as real as possible. So don't just give it the lowest amount of specifications. Don't give it one CPU, don't give it like half a gig of RAM. You want to make it look as real as possible, so you're giving it multiple CPU accesses and multiple gigs. The one that we'll use today, my example, has 2 CPUs and 8 gigs of RAM allocated to it. So you can also install common end user software. Like this would be Microsoft Office, maybe Outlook. Pretty much the Office suite is like one of the best examples. Web browsers across the board would be also good, not just using the default Windows ones or Linux ones. So then you want to also open multiple files and docs. Don't install the guest tool. So in virtual VMware player, workstation player, you don't want to install the VM tools, which make life easy, but it also can revert back to signaling the malware that it's on a VM, and it also creates a new vector of escape. So yeah, then the last step you want to do is make sure you set up a sandbox network, because if you do sometimes block all your ports or remove your network card, like virtual network card, it'll know that it's on a very heavily sandboxed machine. And one tool that Nicole suggests here is FakeNet, which is a website that will help you, or tools that will help you build a network for malware analysis. So we're going to start talking about the actual analysis part. Does anyone have any questions so far? And again, feel free to unmute if you want to. All right. No questions? Moving on then. All right. So here's some questions for you all to kind of like start thinking. And also kind of what any kind of investigator might be wanting to think if you're doing this kind of analysis is, what kind of file is this that we're looking at? Is it a Word doc? Is it executable? Is it Excel file? Is it email, HTML file? Is there any info already known? So when you receive it, do you already know, like have an intuition of what this might be? Like, hey, I downloaded this from a weird website, or it came through a phishing email. And then is it packed? If so, what is it? What packer was it used? So this is, I think we'll talk about a little more detail. So if you're not sure what packed means here, we'll mention that a little bit later. Is there anything unusual in the PE header? So this is the executable header, basically. And then what does a string analysis tell you? So those are some things to get you started thinking about. So again, obligatory word of caution. So treat all public and free malware analysis tools as potential malware, because bad guys want you to look at their stuff, right? So they're going to find ways to defend themselves and also spread bad things. So ensure there's no backdoors to the tools that you use. Think twice before downloading anything, really, right? So this is not just the tools, but also the malware. And also think twice before uploading anything, because sometimes while you're doing analysis and the bad guys find out, hey, somebody's analyzing my malware, that gives me like a heads up that I need to modify it before patches are released. So when you're doing this kind of analysis and find new exploits, make sure you do the right release of like notification to the vendors before you publish. So packers, what are those? These are basically protection mechanisms for malware. You're taking a program and then packaging it inside of a second program. So this, when somebody does like an analysis or just runs it, it shows up as, hey, this doesn't seem too bad. But in reality, it's going to hit a point in the code where it'll switch over to malicious code and start executing the malware payload. So yeah, it makes it harder for them to detect. It also helps with the compression, and encryption can also be used. And then one of the common packers is the ultimate packer for executables, which is shorthanded UPX. File identification. So determining the type of file, there's a couple different things attackers might do, because if you ever noticed, depending on your settings on your computer, the file extension, the actual file extension may or may not be used. So like here, this example, malware.docs.exe. So when you might download this, you might just see the .doc and be like, oh yeah, hey, this is a Word document, it's safe. And that executable portion might be hidden. Of course, depending on your settings, you'll be able to see the executable extension there. And then also archives. So sometimes these pieces of malware are hidden inside zip files, because when you encrypt them, password protect them, it can be hard for malware defenses to see them. And one of the things you can do is, we'll show here shortly in the demo, is using a packer. Like there's a tool that we'll look at that can identify if a packer was used or not. So in inspecting the file properties, signature-based tools include file, which is like a command line tool. It compares the file header with known signatures, because when we'll look at it again more shortly, but there's magic numbers that define what file is what. And so using known signatures, this can kind of compare and give you results using file. exe info PE. So this is a PE is like a family of tools that help with file analysis. So we'll see those a lot. This analyzes the executable header info. TRID, it uses pattern database to determine the type. So it's kind of similar to like what a file might do, but uses a database backend. So here's some just brief examples of screenshots. So in the command prompt, you can see that Nicole was using file and TRD TRID to run against budget report, which is an executable. And yeah, you can kind of see it there. And then also using the GUI executable info PE tool, which is what we'll use in our workshop like demo. It gives you a bunch of information about the compiler and packer information. Another good way to analyze like the structure, or if this is a known malware, is to generate a fixed-length hash. So yes, lots of hashes. Sorry, Tristan, I missed your question. So real quick, what about within files from inside of Excel? Microsoft won't let you edit it because the risk, unless you explicitly allow to do the rest. So where does that fall? I'm not 100% sure what you mean by that, but I'm guessing that kind of leans towards packing. If that's what, is that what you're trying to get at, Tristan? And feel free to unmute if you want to explain it.
Yeah, like I was thinking, like, because Microsoft won't let you edit files, like unless you explicitly click like allow to edit, or yeah, maybe it's more of a scripting, like because their whole thing is like, oh, it's like risky to allow editing unless you explicitly allow it and you know the file.
Yeah, so the portion of like malware and being embedded in Windows like Office products like Word or Excel, the reason why is exactly kind of like what Bowen is saying here is scripts. So there you can actually build macros. Like Windows allows, or Office allows you to use Visual Basic. I forget what the last part of the acronym is, but it's VBA code. You can look it up, and it's like a full-on coding language where you can build out scripts and execute. You can access local file storage and stuff like that even. So yeah, so that's one of the reasons is if you can build malware into these files as macros basically. And so when you open up the file and run it or like start clicking around, you can hide them. You can hide a bunch of stuff in there. Yeah, that's a really, really good, actually, probably topic for a workshop is looking at malware inside of Office products. But hopefully that kind of answers your question. So
yeah, thank you.
Mm-hmm. All right, so yeah, so back to hashes. Sean talked a lot about hashes and password. And this is kind of like the same thing, right? So instead of hashing a password, we're actually going to hash an entire program or file. And so each signature, depending on which type of hash function you use, you're going to get a unique hash for that. So I believe SHA-1 and MD5 both have collisions already created where the file is actually completely different than the original, but they have the same hash result. There's a Google paper I know on PDFs and hash analysis. So yeah. So hashes are fun, and it's a good way to look at them. So how do you calculate a file hash? So on Windows, the easiest way is to use PowerShell with this command that Nicole kindly gave you. So you basically do git file hash, and then you can choose your algorithm, which SHA-256 is probably the most common one to use nowadays. But you'll also see, because of potential collisions, that you'll see all three ran, and then you can use 3 points of comparison rather than just one. You can also use compute hash, which is a GUI program. I've never actually used that one, but that's apparently what Nicole recommends if you like the graphical user interface. Linux, on the other hand, does not have one function or call, one program, but they use one basically for each algorithm. So you can see that you can use SHA-1 sum and then the file, SHA-256 sum file, MD5 sum the file. So very useful for lots of different things. So why hashes? So yeah, so we can use these different like almost search engines, right? VirusTotal is one of the most common ones where researchers upload the hashes of the malware that they find. And we can look at that in a minute. I think Nicole has a screenshot, but it's really helpful to share this information once, obviously, we understand it a little better, because you don't want to upload it directly without understanding it fully, because this, the bad guys also have access to these websites. So it's not like secret information. And yeah, so this is the example that Nicole had. I'm not sure if can anyone actually read that, or is that too small? Thumbs up if you can read it. Okay, cool. All right. Yeah, so you can see here that this is a community score. So this is basically means that the virus companies, right, the engines are finding this. So 58 out of 70 know that this is kind of like a bad one. This is the file name. This is like what happened. These are some tags basically. So it has direct CPU clock access. It can sleep for a long time. It can be found with the P executable. It's got persistence features. And then down here, we can see a bunch of hashes. So MD5 hash, SHA-1 hash, the SHA-256 hash, some other hash functions. You also have what kind of magic header it is, right? Magic numbers, file types. So this is an example of VirusTotal, which is, I want to say, the #1 most used like website for this type of stuff. One thing to note, which I think is coming up, nope, okay, is when you're using free tools, sometimes they will automatically upload as part of the deal, right? Because if nothing's actually ever free, they're always getting something from you, right? If it's free, then you're probably the customer. So if you're using like a free virus analysis tool, it's probably taking all that data that you gather and then uploading it to its database so that it can make money off of it. All right, so demo #1. Let's see here. Nope, you cannot see that. Okay. Share. Do I have to stop sharing? All right, stop sharing. Let's do this again. All right. All right, so hopefully everyone can see my wonderful little sandbox here. All right, so the first workshop we're going to do, or demo, sorry, I'm going to cover here is going to be just kind of doing some file identification. So we have this wonderful malware file, right? And I've just got 8 random files here. They're all file type. Windows doesn't recognize them. Yeah, so basically we want to take a look at these. So what we can do here is let's just randomly pick one of these. And we'll use this program because this is what they use in the workshop. But as we open this up, this is basically a hex editor. There's a lot of different types of things you can look at. But as you can see here, up here, there's a bunch of these numbers, right? Everyone can see that okay? Is that too small? I have a feeling that's too small. If I can zoom in. Yeah, I don't think I can zoom in. But so the first set of numbers here is FFD8. Does anyone know what FFD8 is off the top of your head? If not, it's totally okay. Anyone want to wager a guess? I think you can see it on the screen. Zero. So yeah, so this is a magic number, FFD8. and that is for JPEG files, which is kind of given away when you see the JFIF here. All right, so let's try another one. So we'll do the same thing with this one. All right, so this one has a much longer actual like magic number. Oh, hex number. Yeah, so this one is actually going to go all the way to 31. And you can see it kind of highlights as I highlight the hex, it highlights over in the ASCII output. And so this is RTF. Is anyone like familiar with what that is? Yeah, rich text, exactly. All right, yeah, so this is kind of like one way to do this. There's lots of tools in order to do this on Linux and Mac and obviously Windows. So it's kind of like stage one of trying to do file analysis is to look at the magic numbers. Because when we did that, we're not actually ever executing the file. So even if this was malware, we wouldn't be necessarily running that executable. All right. I think that's actually it for this one. All right. So let's go back to the slides. So I guess before I move on, are there any kind of questions of like the easy way to do file analysis? All right, cool. All right, so embedded strings. So I guess I could have done this one at the same time. All right, so types of strings. We've got ASCII, which is everyone, I think if you're in computer science, would be kind of familiar with. This is what a lot of people use. Unicode is also very popular in like the Word documents and internet, stuff like that. ASCII is more of like programming side stuff. So yeah, so make sure you are getting both types of this data out of the files, because depending on who's programmed this and where they came from in the world, their standards or malicious intent might be different. So two good programs to use for doing this kind of analysis is Strings, which is available on all operating systems, Windows, Mac, and Linux. And Bentex is a GUI version of Strings, basically, which it runs on Windows. I'm not 100% sure if it runs on other operating systems, but if you use Mac and Linux, you'd probably use comfortable enough with the command line tool that you don't have to worry about it. All right. So hidden strings. So why are we looking at these hidden strings? Does anyone have any like guesses of why we might be looking at hidden strings? Nobody? Anybody? Take a guess. No wrong answers. I promise. Yeah, looking for something that looks off. Yeah, that could be definitely one thing, right? Yeah, and creator information. That's actually a good one. DNS flush what? Yeah. Okay. Yeah, there's some interesting examples, I guess, here, huh? Yeah. All right. Yeah, so I think those are some good guesses, and that's accurate, right? So the nice thing about strings is it'll tell you all sorts of fun stuff, which we will take a look at here shortly. So the random strings, there's a lot of them, so you got to be careful. But encrypted strings, so sometimes also people will be hiding the information in base 64 or even XOR data, right? Those are probably like some of the most common ones used in code, just because it's simple to go back and forth between them. So when you actually look at these, oops, went too far, too fast. Yeah, so when you actually are doing like hidden string analysis, you'll want to actually not just look at the raw output, but also convert it back to base64, like convert it from base64 or X4, that information. So another tool, which is interesting, is using XOR search. So this is a downloadable program, but Windows loves it and calls it a virus. The creator says it's a false positive. I didn't have time to like try to figure out how to get it to work because Windows is, blocking it right now. So go have fun with that one. But Nicole did have it, so I wish she could have done this because she has it. So yeah, so look up, she's suggesting here, look up this, right? Because if you find this phrase, this program cannot be run in DOS mode, we're going to know that that's an executable. So that might be hidden deeper into the strings because that's the starting of an executable file. ACP, right? So a lot of files probably don't need to have any URLs embedded in them. So this might be a sign that it's planning to make a call off of the host device, which is potentially malware. Kernels, so anything that's touching the kernel and you're using it, and is probably a bad thing. Like most of the kernel code should be hidden from users. Create, and then so there's a large number of create objects. Again, memory can create stuff, but this shouldn't be necessarily the same calls that are used at user level. All right, demo number 2 is actually going to be wrapped into demo number 3 for me because it's just easier to process them all at one time. So we're just going to skip through this unless anyone has any questions so far. We're still doing good. I know everybody's just thinking like, why don't we just like actually release malware and have some fun, right? So, all right. So yeah, looking at the P header. So P header, what is this? This is P, it's a portable executable. So these are the little .exe files that you move around all over the world. It provides the operating system information needed to run the program. So it says, hey, this is the libraries we're going to need and stuff like that. It also can be packed or unpacked information. All right. So some key tools that we'll be looking at today is mainly PE Studio and like the family of PE products. Another one is the CF Explorer, which you can kind of see that they give a lot of good information, but PE Studio is a lot more specific for malware analysis than I am aware of. All right. So that was nice and short. So we're going to jump back over, if I can find it, to my wonderful malware sandbox. All right. So let's see here. So we're going to go back up into the malware box. So we have here a bunch of unknown files, so potentially malware. So yeah, so we'll go ahead and start this off. Okay. So let me go ahead and I'm just going to cd into it because it makes it life a little easier. Actually, I just need desktop. Oh, no, it's actually, let's see. Malware unknown. Okay. There. Okay, so here's the files, the unknown ones that I wanted to take a look at. So we'll go ahead and do strings first because that's what we kind of skipped with the demo too, is using strings. So what we're doing here is strings, and it's an S, if anybody didn't capture that. Yes, Bob. Bob was not my name choice. Sorry. If anyone's named Bob, I'm not attacking you. This came like this. All right, yeah, so we're going to do in8 is going to give us 8-character words, just so we can kind of look at them. All right, and we'll pipe this into more because there's a ton of output. All right, so does anything jump out at you from what we were talking about earlier on this one? Just looking at this first set of output. DOS mode, yeah. So Samuel, do you remember what we were talking about with this cannot run in DOS mode, what that meant? Yep, yeah, exactly. It's executable. And yeah, Grant, that's true. This isn't an executable what we're looking at. I don't think this extended as far as it needed to extend. What's up? There we go. Okay, so there's some more here that also looks pretty interesting. So you can see we kind of got some garbage up here. And then this is one of the key steps here that also kind of shows you some other stuff happening. Yep, yeah, exactly. So we start accessing some stuff, but we also have like an unzip. So it's telling itself like, hey, we have something hidden in here. Let's get it out. And yeah, so then we start getting into some really fun system calls. So set file time, read file. Let's see. Let's see here. Yeah, you kind of get the hint of it. This was, oops, did I pass it? Oh yeah, reg set value. Like obviously this is going to be really interesting because we're starting to look at the kernel 32, which was one of our hint identifiers, right? And another DLL file, a library file, and editing the registry. Oh, this is kind of cool. Crypt. I wonder what crypt does. What does anyone think what crypt might do? Like why they might be calling crypt on this? Let's see. Oh yeah, look at that. WannaCryptor. That might be an interesting clue. Anybody figure out what this might be that we're looking at? Oh wow, there's some Chinese, Croatian, Czech language, all the languages in the world, Vietnamese, and then more random junk. Yep, yeah, Tristan, there you go. Ransomware. That's right. That's oops. That's what we're looking at here. All right. So yeah, so we'll also do another tool from the PE family this time. So PID. So this one is going to just we're going to drop the file onto it, and we'll be able to get some similar information of just like what the file is. So I know this might be kind of hard to read. Hopefully you can all read it okay. But the entry point, so this is basically extracting the executable file in here. So it's entry point in memory. It starts in the .text. So if anyone here, has anyone taken CSC 30? You can all raise your hand. Woo woo. Fun class. Subsystem. So we know it's a Win32 GUI. And then here is what was the package packed with, which is Visual C++ 6.0. So that's all that PID does, is just gives you a good hint of where to start with these files. All right. Any questions so far? Everybody kind of following along? I'm not going too fast. No pressure, no pressure. Yes, somebody has a question.
Hello? Oh, okay. So this is kind of unrelated, but can you remind me of why the names of the Windows syscalls are stored as strings in the program?
That's actually a good question. I'm not 100% sure. I believe that it has to do with the fact that it's packaged as code, not necessarily as like compiled executable, is what if I believe that's correct, because that's how it's getting through like onto a system, and it's hidden in there. I think that's right, but I'm not 100% sure.
Okay, thanks.
Does anyone else in the crowd know the answer to that question? No, but yeah, I'm pretty sure, because I know there was a recent malware that used its, like, it downloaded its own compiler, like a custom compiler just for that malware. So that's why I'm guessing that. All right, so moving on, we'll go back to this PE Studio, the one that we had mentioned earlier in this. All right, so again, nice and easy. These tools are fairly modern now, right? We can go ahead and just take the file and drop it on there. So this is going to take a minute to analyze completely, but we can at least start taking like a brief look at it. So we'll go ahead down to this version and kind of just get some of the information. So this tool is pretty cool. It gives us some hashes for us already of the file. So it already ran those hashes, so we didn't have to manually do it. It tells us what type of file it thinks it is, which is a dynamic link library, the DLL files. And so the original name of this file is dispart.exe. So this is actually like a system library tool, which will go and check out the original here shortly. Since this is a Windows machine, we'll be able to find it. And yeah, I think while it's loading, we can take a look at the original one. All right, so let's go ahead and where'd my mouse go? Okay, there's my mouse. All right, so let me go back. CD. Wait, unknown was right. Windows. Okay, so we are going to string again, right? Just real quick, we're just going to do the head of it. So it was the string HN8 of ed. Okay. Can I do head? No, head is only on Linux. Okay, we'll just do more. Okay, so this is going. We're going to do. I'll open up a second one, and we'll look at the real dispart, which is cd / Windows system 32. Okay, I didn't get to it. Okay, but I know it's here. So strings -n 8 and diskpart.exe and type to more. Okay, and what I forgot the end. Okay. Okay, so yeah, so what we have here, right, is this is on the left side is the unknown file that we're analyzing. Obviously, it's some kind of malware. And then on the right side is the actual dispart.exe that is on this Windows machine. So if we scroll through, you can kind of see it's the same kind of random strings. Here's some other strings in here that seem kind of normal. And if we just scroll down through here, you can kind of see we don't have any of that through all of these malware related ones. And then we got all the language files. I think at some point we get back to the other ones, but it's like way down here probably. And it's because I'm running more. That's the terminal. But you can kind of see that there's 0 similarities between the 2 files. So obviously one is bad and one is good. Let me quit this one, quit that one. So then what we can do here is, let me take a look at what the command actually says to do. Okay, so we'll open up PowerShell and just create hashes of them. PowerShell. Okay, so we can just do get file hash from earlier. I think I spelled that right, and we'll just do MD5. Actually, I like SHA 256 because 256 is rare. 256, and then we will do C. Actually, I think I can just do yes, C/malware unknown and spell ED. Okay, so that oh, I can't spell algorithm. How? Cool. There we go. All right, and then we'll do the same thing on the good file, just to kind of show off what this is doing here. Okay, so yep, here's the same there, like the output, right? So 256, again, my favorite one right now for hashing. We can kind of see these two are clearly different. So the content is not accurate. We use the same, hence it would be malware. Okay. Okay, so let's jump back to the P studios to see what the status is. All right, cool. So let's take a quick look at resources. So this kind of gives us some information on these are like the resources that are required for the executable to run. So it might be icons or dialogues that pop up. The attackers, they can utilize these resources section to store additional malicious files, sometimes to be encrypted to help, evade analysis. They also might contain data like payloads, droppers, configuration info. So it's pretty useful because it's going to contain information about the origin of this binary that we're looking at. So sometimes, what we're doing here is we're looking at basically the resources of what the program needs, right? So it needs version numbers, manifest. It has a pkzip signature, so that's like the kind of the file that's hidden inside the zip executable. So these are like the different hashes of the file ratios. So the full size, entropy. So typically, like as the entropy grows, that's like the more kind of oddities within this file. All right. And then language. Here, I forgot about language. This sometimes may or may not be relevant depending on like where this is coming from, because it's pretty easy to set this to anything, but you never know. Some people might forget, to hide where they actually live. All right. So another nice thing about this P Studios is we have this section called indicators. So this is kind of highlighting things to us that might make us think that this is bad file, right? So there's some things we've already kind of looked at. So the size of a resource is suspicious, right? So like, why is it asking for this? And it's obscenely large. And something we kind of looked at already was strings that this program calls are on a blacklist. So these are things that we don't want people using normally. So it also references MITRE techniques. So this would be, if anyone's familiar with MITRE, like you want to briefly mention what MITRE is in cybersecurity. So I'm taking it that nobody knows, but that's okay. So MITRE is a fairly large, I believe, nonprofit. I could be wrong about on the profit status, but yeah. So yeah, it's a company and nonprofit. Thank you, Tristan, for that. They basically do a lot of research into vulnerabilities. They collect information. They also have like the MITRE attack framework, which kind of breaks down cyber attacks, like pen testing and stuff like that. They use it often. Well, yeah, nice. Yeah, so MITRE, it's you'll hear that name a lot. So basically this techniques it's talking about is inside of this malware, they're using techniques to attack the computer. MITRE has collected these techniques and provided it for people to do analysis and identify these problems. All right, and I think that's kind of like the end of the demo for the intro part. There's definitely a lot more out there to look at. But yeah, so I think that's kind of wraps everything up. We're still in that perfect 1 hour mark. So does anyone have any questions about what we kind of covered today, or maybe we didn't cover something that you were really hoping to learn? Yeah, thanks, Bryce, for coming. Hopefully you enjoyed it. Yes, thanks to Nicole. Everyone go to Discord, ping Nicole, say thank you, because this is, again, all of her work. I can't thank her enough for it. All right, I guess if there's no other questions, I'll hang out, but I'm gonna go ahead and stop the recording.
Everyone copy paste that same message. The